So if our goal is to graph a line, we get information from the equation of the line. If the line is in slope-intercept format, y equals mx plus b, we can get the y-intercept of the line from the back and the slope of the line from the number next to x. So let's look at the first example. This problem is currently in what's called standard form, which is another way to write the equation of a line, but it doesn't give us information right away. So we're going to isolate y to get it into slope-intercept form. We subtract 2x, which gives us 3y equals negative 2x plus 21. And then we just divide absolutely everything by 3. I will get y equals negative 2 over 3x plus 7. What I now have is the equation of a line in slope-intercept form. I see my slope is negative 2/3. I see my y-intercept is 7. To graph this line, I start with the y-intercept. You always start by putting a point at the y-intercept, which is where your line touches the y-axis. In this case, we have a y-intercept of 7. We then use the slope to stair-step to get more points. So the slope is the second thing you use when you're graphing a line. I start here and say I have a slope of negative 2/3, which means I can go down to forward 3, down to forward 3, down to forward 3. I'm using the idea that the slope is a rise of down 2 and a run of forward 3. You also could write this fraction 2 over negative 3. You could rise 2 and go backwards 3, up to backwards 3. All of those points are on this line, which means they're all partner pairs x, y that make the equation true. We connect the dots and put arrows on the end to show that this line continues infinitely in both directions.